Implementation of Zhuque-3 rockets reusable technology by Q4 2024. Introduction. The Zhuque-3 rocket developed by the Chinese commercial aerospace company LandSpace is on track to implement reusable technology by the fourth quarter of 2024. This initiative aims to revolutionize China's space launch capabilities and significantly reduce costs associated with satellite deployment. With an estimated budget of $10 million earmarked for engine upgrades and structural reinforcements, the project has already achieved critical milestones, including a successful ground ignition test conducted on June 20, 2025. Overview of Zhuque-3 rocket. The Zhuque-3 is a two-stage launch vehicle designed for reusability and efficiency. It boasts a length of approximately 66 meters and a diameter of 4.5 meters, allowing it to carry multiple payloads to low Earth orbit (LEO). The rocket is engineered to be flown at least 20 times, promising a substantial reduction in launch costs, estimated to be up to 90% lower compared to traditional single-use rockets. This capability positions Zhuque-3 as a competitive player in the burgeoning global commercial launch market. Key phases of implementation. The implementation of reusable technology for the Zhuque-3 rocket is structured around four key phases. Phase 1: Ground testing and validation. Completion of ground test. The first significant milestone was achieved on June 20, 2025, when LandSpace successfully conducted a comprehensive ground ignition test of the Zhuque-3's first-stage propulsion system at the Dongfeng Commercial Space Innovation Test Zone. This test involved the firing of 9 self-developed Tianke-12 liquid oxygen methane engines producing a total thrust of 7,542 kN during a 45-second test period. Simulation of flight conditions. The test closely replicated actual flight conditions, covering the entire launch sequence, from propellant loading to engine ignition and shutdown. This level of fidelity is crucial for validating the complex 9-engine propulsion system necessary for future missions, including vertical recovery flights. Phase 2: Engine upgrades and structural reinforcements. Budget allocation. With an estimated budget of $10 million, LandSpace plans to upgrade the engines and reinforce the rocket structure to enhance reliability and performance. Focus on reusability. The upgrades are aimed at ensuring that the first stage can be recovered and reused multiple times, similar to conventional aircraft operations. The structural reinforcements will also help the rocket withstand the stresses of multiple launches and recoveries. Phase 3: Orbital launch preparations. Inaugural flight scheduled. Following successful ground tests, LandSpace is preparing for its inaugural orbital launch attempt, initially set for the third quarter of 2025. This mission will serve as a critical test of the rocket's capabilities in a real-world scenario. Payload considerations. The inaugural flight will carry a prototype of the reusable Haolong cargo spacecraft, which is designed to facilitate low-cost cargo delivery to the Tiangong space station. Phase 4: Recovery and future missions. Recovery attempts. LandSpace aims to initiate recovery attempts by 2026, a significant step in demonstrating the true reusability of the Zhuque-3. This phase will involve capturing the first stage after launch and ensuring it can be refurbished for subsequent flights. Long-term vision. The successful implementation of reusable technology in the Zhuque-3 will pave the way for future missions, enhancing China's position in the global space industry and providing more cost-effective solutions for satellite deployment. Technical milestones and achievements. The successful completion of the ground ignition test marks a significant achievement for LandSpace and China's aerospace ambitions. The test validated several critical components. Synchronization of engine ignitions. The successful ignition of all 9 engines in a controlled manner demonstrated the rocket's ability to handle complex propulsion systems. Stable combustion. The test confirmed stable combustion across all engines, a crucial factor for reliability during actual launch scenarios. Subsystem integration, validation of the integration among all major subsystems, engines, pressurization and delivery systems, structures and avionics, was successfully achieved, laying the groundwork for future missions. Future implications. The advancement of reusable rocket technology through the Zhuque-3 project not only positions LandSpace as a leader in the commercial space sector but also aligns with China's broader goals of enhancing its space capabilities. The ability to significantly reduce launch costs opens up new opportunities for satellite deployment and other space ventures. Conclusion. The implementation of reusable technology in the Zhuque-3 rocket signifies a crucial step forward for China's aerospace industry. With successful ground tests already achieved and plans for orbital launches on the horizon, LandSpace is poised to make significant contributions to the future of space exploration and commercial satellite deployment. The journey toward reusable rockets represents not only a technological advancement but also a strategic move to ensure China remains competitive in the global space race. The implementation of reusable technology in the Zhuque-3 rocket by LandSpace, set for Q4 2024, reveals several counterintuitive aspects of its development and operational strategy. 1. Cost efficiency versus reusability goals. While the Zhuque-3 aims to reduce launch costs by up to 90% compared to traditional rockets, the budget for engine upgrades and structural reinforcements is relatively modest at $10 million. This suggests that achieving significant reusability may not necessarily require extensive investment, challenging the common belief that advanced aerospace technologies demand massive funding. 2. Technical complexity understated. The achievement of successfully conducting a ground ignition test of the 9-engine propulsion system is being hailed as a breakthrough. However, the complexity involved is significant. Synchronizing multiple engine ignitions and validating intricate subsystems are often underappreciated. This complexity is not just a technical hurdle but a critical factor that could influence the timeline and success of future recovery attempts. 3. Performance expectations. There is a discrepancy in the reported specifications of the Zhuque-3 rocket, particularly regarding its length and payload capabilities. The latest reports indicate a reduction in length from 76.6 meters to approximately 66 meters, which could imply a lower payload capacity than initially expected. This suggests that the rocket's design may be more constrained than previously believed, yet the operational capabilities could still meet or exceed mission requirements, highlighting that size is not always directly correlated with performance. For public perception versus technical reality, the media and public narratives often emphasize the Zhuque-3 as a symbol of China's rapid advancements in space technology. However, the reality is that significant milestones still lie ahead, including the need for safe recovery and reuse demonstrations. The emphasis on the success of ground tests can create an impression of readiness that may not align with the technical and operational challenges still to be addressed. 5. Private sector versus state involvement. The Zhuque-3 project is framed within the context of China's private aerospace sector, yet it has received substantial funding and support from state initiatives like the $123 million from the National Manufacturing Transformation and Upgrading Fund. This relationship blurs the lines between public and private efforts in space exploration, countering the narrative that private companies operate independently of governmental influence or support. 6. Future recovery attempts. The ambition to initiate recovery attempts by 2026 is noted as a significant milestone. However, this timeline is aggressive and may not account for the complexities of developing reliable recovery systems for large rockets. The expectation that these attempts will succeed soon after the inaugural flight could mislead stakeholders about the challenges inherent in reusability. In summary, while the Zhuque-3 rocket represents a significant step forward for China's aerospace capabilities, the interplay of technological complexity, funding requirements, and public perception reveals a nuanced landscape that challenges conventional wisdom about the development and operation of reusable rocket technology. The report on the implementation of reusable technology for the Zhuque-3 rocket is packed with significant details that deserve closer examination. While many readers may focus on the general advancements and the successful ground tests, there are several critical points that often get overlooked. Here are those key aspects along with an explanation of their significance. 1. 9-engine propulsion system. The Zhuque-3's 9-engine propulsion system is a pivotal element of its design. The complexity of this system is highlighted by the successful coordination of multiple engine ignitions in stable combustion during the recent ground test. This achievement is significant because technical complexity. Coordinating 9 engines requires advanced engineering and precise timing. It demonstrates LandSpace's capability to manage complex systems, which is crucial for future missions involving multiple engines operating in tandem. Path to reusability. A reliable multi-engine system is essential for the rocket's planned reusability. If the engines can perform consistently, it will enhance the safety and reliability of recovery attempts, paving the way for more sustainable space missions. 2. Cost reduction potential. The report mentions the Zhuque-3's potential to reduce launch costs by up to 90% compared to traditional single-use rockets. This aspect is often overshadowed by the technical achievements but is incredibly important because market impact. Lower costs could make space access more affordable for a wider range of customers, potentially increasing the frequency of launches and the number of satellites in orbit. This can also stimulate innovation in satellite technology and services. Competitive advantage. In an increasingly competitive global space market, the ability to offer lower launch prices can position LandSpace as a formidable player against established companies like SpaceX, which has dominated the reusable rocket sector. 3. Integration and system validation. The successful validation of all major subsystems during the ground test is a noteworthy achievement. This integration is significant because comprehensive testing, the rigorous approach to testing, which mimicked actual flight conditions, is critical for ensuring that all components will work together seamlessly during a launch. This reduces the risk of failure during the maiden flight and subsequent missions. Foundation for future missions. By proving that all systems can work in concert, LandSpace sets a solid groundwork for future missions, including the anticipated vertical recovery attempts, which will be a crucial test of the rocket's reusability. 4. Material and structural advancements. The use of high-strength stainless steel for the rocket's construction is a detail that might be missed but holds substantial importance. Durability and cost efficiency. Stainless steel offers better thermal properties and durability compared to traditional materials used in rocket design, which may contribute to longer operational lifespans and reduced maintenance costs for reused rockets. Innovation in manufacturing. This choice of material represents an innovative approach within the industry, indicating a shift towards more resilient and cost-efficient designs that could influence future rocket architectures globally. 5. Regulatory and industry implications. The report implies that the Zhuque-3 project is a part of the broader trend of increasing commercialization in China's space sector. This is significant for several reasons. Policy environment. The growth of private companies like LandSpace indicates a shift in China's approach to space exploration, moving towards a more open market model. This could inspire more private investment and technological advancements in the sector. Competitive landscape. As more private entities enter the space industry, competition may lead to faster advancements in technology and production, ultimately benefiting the entire space exploration community. 6. Future launch plans and recovery attempts. The timeline for future launches and recovery attempts is another critical aspect that deserves attention. The planned orbital launch in Q3 2025 and recovery attempts by 2026 reflect strategic milestones. These timelines indicate LandSpace's ambition to quickly iterate on its technology, which is essential in the fast-paced aerospace industry where time to market can be critical. Long-term vision. Establishing a recovery program is a cornerstone of the reusability model. Successfully returning and reusing rocket stages could revolutionize launch economics and solidify LandSpace's position in the market. Conclusion. In summation, while the report on the Zhuque-3 rocket covers various technical milestones and plans, it is the overlooked details regarding engine complexity, cost reduction, potential system integration, material innovation, regulatory implications, and future launch plans that hold profound significance. These elements collectively shape the narrative of not just LandSpace's ambitions but also the future of reusable rocket technology in the global aerospace landscape. Understanding these aspects can provide deeper insights into the potential transformations within the space industry driven by advancements in reusability and commercialization efforts. Here are the 4 most valuable points for in-depth analysis and discussion on the implementation of Zhuque-3 rocket's reusable technology. 1. Significance of the ground test completion. The successful completion of the ground ignition test on June 20, 2025 represents a crucial milestone in the development of the Zhuque-3 rocket. The test validated the rocket's complex 9-engine propulsion system, producing an impressive thrust of 7,542 knots over a 45-second duration. This test not only marked the highest level of complexity achieved in China's rocket testing to date but also laid essential groundwork for future vertical recovery and reuse capabilities. The ability to simulate actual flight conditions highlights the technological advancements made by LandSpace as they strive to enhance the reliability and safety of their launch systems. Analyzing the implications of this achievement could lead to discussions around how it positions China in the global space race, especially in terms of reusable technology compared to established players like SpaceX. 2. Technical innovations and challenges. The Zhuque-3's design features several technical innovations, particularly its use of the Tianke-12, a liquid oxygen methane engines, and a stainless steel structure. The rocket's specifications allow for a significant payload capacity while aiming to achieve reusability with a target of at least 20 flights per first stage. However, this ambitious goal also comes with inherent challenges such as ensuring the structural integrity and performance of the engines after multiple uses. Furthermore, the synchronization of multiple engine ignitions and maintaining steady combustion stability during flight are critical technical hurdles that must be addressed. An in-depth analysis could explore the engineering solutions proposed by LandSpace and how overcoming these challenges could set a new standard for rocket reusability. 3. Economic implications of reusable technology. The implementation of reusable technology in Zhuque-3 is projected to reduce launch costs by up to 90% compared to traditional single-use rockets. This cost reduction is pivotal in making space more accessible for satellite launches and other commercial applications. The estimated budget of $10 million for engine upgrades and structural reinforcements reflects a strategic investment aimed at long-term gains in the competitive commercial space launch market. Analyzing the economic implications of this reusability model could lead to discussions about how it might disrupt the current space launch industry, affect pricing strategies, and influence market dynamics, particularly in emerging markets. 4. Future plans and strategic objectives. Following the successful ground tests, LandSpace's roadmap includes an orbital launch attempt in Q3 2025, which aims to carry a prototype of the reusable Halong cargo spacecraft. The company is also targeting the initiation of recovery attempts by 2026. These future plans indicate a clear strategic vision to establish a foothold in the burgeoning market for reusable launch vehicles. A closer look at these objectives could facilitate discussions on the potential impact of Zhuque-3 on China's broader space exploration goals, including its ambitions for low-cost cargo delivery to the Tiangong space station and beyond. Furthermore, assessing LandSpace's competitive positioning vis-a-vis other commercial space ventures could provide insights into the future landscape of space exploration and utilization. In summary, these 4 points encapsulate the technological, economic, and strategic dimensions of the Zhuque-3 rocket program, offering a comprehensive basis for further discussion and analysis. 1. NASA's Space Shuttle Program 1981 to 2011. The Space Shuttle program is one of the most well-known examples of reusable rocket technology. Initiated in the 1970s and launched for the first time in 1981, the Space Shuttle was designed to transport astronauts and cargo to and from low Earth orbit. The shuttle's main components, including the orbiter's solid rocket boosters and external fuel tank, were engineered for reuse. The orbiter could be refurbished and flown multiple times with the goal of decreasing the cost of access to space. Over its 30-year operational history, NASA successfully completed 135 missions, including the deployment of satellites, construction of the International Space Station ISS, and servicing of the Hubble Space Telescope. However, the program faced challenges, including two tragic disasters, the Challenger in 1986 and Columbia in 2003, that highlighted the risks associated with space travel. 2. SpaceX's Falcon 9 2010 present. SpaceX revolutionized the space industry with the development of the Falcon 9 rocket, which features a reusable first stage. First launched in 2010, the Falcon 9 has undergone numerous upgrades, allowing it to land back on Earth after delivering payloads to orbit. The first successful recovery of a Falcon 9 first stage occurred in December 2015, and since then SpaceX has repeatedly demonstrated the ability to refurbish and reuse these boosters. This technology has significantly reduced launch costs, making space access more affordable and paving the way for future missions, such as crewed flights to the ISS and planned missions to Mars. The Falcon 9's reusability has become a benchmark for other companies in the aerospace industry. 3. Blue Origin's New Shepard 2015 present. Blue Origin's New Shepard is a suborbital rocket designed for space tourism and research missions. The rocket is fully reusable with a focus on vertical takeoff and landing capabilities. Since its first uncrewed flight in 2015, New Shepard has successfully completed multiple test flights, demonstrating the ability to carry payloads and tourists to the edge of space before safely returning to the launch site. The reusable nature of New Shepard is a key aspect of Blue Origin's strategy for reducing costs and increasing the frequency of flights. In July 2021, New Shepard successfully completed a historic crewed flight with Jeff Bezos and others aboard, marking a significant milestone in commercial space tourism. The program continues to evolve, with plans for future missions and enhancements to its reusable technology. The Zhuque-3 rocket, developed by LandSpace's, is poised to revolutionize China's commercial space industry with its planned implementation of reusable technology by Q4 2024. This initiative represents a significant leap forward in the realm of launch vehicles, with major implications for cost efficiency and mission frequency. Here's an outlook on the future developments associated with this project. 1. Implementation timeline and phases. By the end of 2024, LandSpace aims to complete critical upgrades to the Zhuque-3's propulsion system and structural design, with a budget of approximately $10 million earmarked for these enhancements. The development will unfold in 4 key phases. Phase 1, Engine Upgrades, Q4 2024. Focus on optimizing the Tian K-12A engines to ensure they meet the demands of multiple launches and reusability. This includes enhancing thrust efficiency and durability. Phase 2, Structural Reinforcements, early 2025. Strengthening the rocket's first stage to withstand the stresses of re-entry and landing, ensuring it can be reused at least 20 times as designed. Phase 3, Ground Testing and Validation, mid-2025. Following the enhancements, extensive ground tests will be conducted to validate the integrated system performance. This will include multiple hot-fire tests and simulations of flight conditions. Phase 4, Maiden Flight and Recovery Attempts, Q3 2025 and beyond. The inaugural orbital launch is expected in Q3 2025, carrying a prototype of the reusable Halong cargo spacecraft. Recovery attempts will begin in earnest by 2026. Establishing the rocket's operational capabilities. 2. Technological innovations and cost reductions. The Zhuque-3 aims to achieve unprecedented cost reductions in space launches, potentially lowering expenses by up to 90% compared to traditional expendable rockets. This is facilitated by reusability. The ability to recover and refurbish rockets after launch allows for a more sustainable and economical approach to space travel. High thrust capacity. With a total thrust of 7,542 knots generated by 9 engines, the Zhuque-3 can carry significant payloads, enhancing its appeal for commercial satellite deployment and future cargo missions to space stations. 3. Impact on China's space ambitions. The success of the Zhuque-3 is integral to China's broader ambitions in space. By advancing reusable technology, LandSpace positions itself as a key player in the global launch market. This initiative will enhance national capability, strengthening China's position in the space race, particularly in reusable technology, which is critical for future exploratory missions and satellite deployments. Support commercial ventures. Lower launch costs will attract private enterprises and international clients, fostering a more competitive aerospace sector. 4. Future prospects and challenges. While the outlook for the Zhuque-3 is promising, several challenges must be navigated. Successful recovery. The transition from launch to recovery is complex, requiring precise engineering and operational protocols. Successful recovery missions will be vital for demonstrating the rocket's reusability. Regulatory and market dynamics. As the commercial space sector evolves, LandSpace will need to adapt to regulatory changes and market competition, especially from established players like SpaceX and Blue Origin. 5. Long-term vision. Looking beyond 2026, the implications of the Zhuque-3 and its reusable technology could lead to increased launch frequency. The ability to rapidly reuse rockets could enable more frequent launches, expanding opportunities for satellite deployment and interplanetary missions. Innovation in cargo transportation. The Halong spacecraft could facilitate routine cargo missions to the Tiangong space station, bolstering China's ambitions in low Earth orbit. In conclusion, the Zhuque-3 rocket represents a significant milestone in China's quest for advanced aerospace technology. As the project progresses towards its maiden flight and recovery attempts, it is set to shape the future of space exploration and commercial satellite deployment, underscoring a pivotal shift towards sustainability and efficiency in the aerospace industry. The successful realization of these goals will not only enhance China's technological stature but also contribute to the global evolution of reusable launch vehicles.